All right, so we're talking today about dilations, and this fits under the big heading of transformations. We've already done some other transformations in Unit 6. This is going to be the major one that we've saved for Unit 7 because it involves changing size. The 3 that we did in Unit 6 involved other changes, but not a change in size. So here we go. Multiplying the coordinates by a number will change the size of the figure. So for example, if we go with a transformation of 3x comma 3y, we're going to multiply both the x and y coordinate by 3. So the negative 3 times 3 would be negative 9. Negative 1 times 3 would be negative 3. Negative 1 times 3 would be negative 3. Negative 3 times 3 would be negative 9. You get the picture. I'm going to multiply each one of these coordinates by 3. And the only one that sometimes is weird, right? If you have a 0, 0 times 3 is 0. And you'll see what happens on the diagram itself. So what I have on here is the original shape, right? A, B, C, D, E, no tick marks. So A prime is negative 9, which is left 9, down 3. And that's going to be A prime. B prime is negative 3, negative 9. C prime is positive 3, so to the right 3, negative 9. D is 9, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3. And E prime is 0, 6. So the one that didn't do the same movement as the rest, like you'll notice A got like further left and lower. B got lower and further left. C got lower and further to the right. E is the only one that didn't really do that because E only moved straight up. If something is on an axis and you're multiplying only, it will stay on that axis. So when I go to connect these, you are going to hopefully notice something about the new shape, other than my wiggly line segment there. You are going to notice that because we multiplied both the x and the y coordinate by 3, the shape stayed similar. It changed size, right? It definitely got larger. This segment here that was a 2, now this segment down here is a 6. It got larger, but it did not change shape. It is still the same shape pentagon, and angles stayed the same. So the two shapes are similar. Write a mathematical statement saying the two figures above are similar. So we would say, now notice I'm not going to put a triangle symbol because this is not a triangle. I'm going to say A, B, C, D, E is similar to, and then you'd start with A. So on this shape, you'd start with A prime and then work your way around in the same order, just like we did before when we were naming two shapes. The amount that the coordinates is multiplied by is called the scale factor. It represents the ratio of corresponding sides. What is the scale factor for the previous figures? So we multiplied by 3, or you can say that it is a 3-to-1 ratio. Notice that the image is larger than the original figure. When the coordinates are multiplied by a number greater than 1, it is known as an enlargement. So I'm just going to make sort of an extra notice of that. This one was an enlargement. It started small and got bigger. The second shape, right, makes sense. This time we're going to multiply by a number smaller than 1. So this time we're going to multiply by 1/2. So we're multiplying both coordinates, right? Negative 8 times a half, 4 times a half, negative 2 times a half, negative 1, 8 times a half, 6 times a half, negative 4 times a half. And those coordinates are also going to change the size, but not the shape, because both times I multiply by the same number, times 1/2 times 1/2. So my new shape, negative 4, 2, and negative 1, 4, and positive 3, negative 2, those are going to be my E prime, F prime, G prime. I am doing it in another color just so you can tell the difference between the original and the image, but you can see that it got significantly smaller. Write a similarity statement for the figures above. So in this case, they are triangles. So we're going to say triangle EFG, and we need to name the second one in the same order, is similar to triangle E prime, F prime, G prime. Usually we start with the original. What was the scale factor? What was the number we multiplied by? 1/2. Notice the image is smaller than the original figure. When the coordinates are multiplied by a number greater than 0 and less than 1, it's known as a reduction. So notice I didn't multiply by a negative. I multiplied by something between 0 and 1. So that would either be a fraction or a decimal. We can also look at some that are already done. So like this one starts large and gets small. So what is the scale factor from PQRS to LMNO? So I'm going from the large one to the small one. So we know that it's a reduction, which means it's got to be one of those 0 to 1 numbers, like a fraction. 6 goes down to 3, 5 goes down, doesn't say. 8 goes down to a 4, 4 goes down to a 2. So the scale factor is 1/2. But if I go in the other direction, LMNO up to the larger one, that one would be an enlargement. And I'd have to think 3 times what will give me 6, 4 times what will give me 8. And in that direction, the enlargement would have a scale factor of 2. A, B, C, D to M and O, P. So I'm going from the large one to the small one. That would be a reduction. And I'm going from 6 down to 4. Or I'm going from 3 down to 2. So it got smaller. We all agree on that, right? So that means it's not a 6 to 4 ratio. We're not going to say it's going from 6 to 4. We're going to say that this one that we end up with is 4/6 of the original. And in lowest terms, that would be 2/3. Or you could look at this one, 2/3. So the scale factor is 2/3 because it's a reduction. The easy part is you can go in the other direction, like enlargement, right? From M and OP, from the small one up to the big one, just by using the reciprocal, by flipping that fraction over. So in one direction, it's 2/3. In the other direction, it's 3/2. This actually was the same, 1/2. This is really just 2/1.